3D printing, also known as additive manufacturing, is a fabrication process that involves creating three-dimensional objects by depositing successive layers of material. The process is controlled by a computer, which follows a digital 3D model as a blueprint. Here is a detailed step-by-step guide to the 3D printing fabrication process. 1. Design and preparation. To begin the printing process, a 3D model must first be created using 3D modeling software like Blender, Tinkercad, or Fusion 360. If preferred, pre-existing models can also be downloaded from online repositories such as Thingiverse or Miminifactory. Next, the model must be converted to a printable format by an engineer. This involves exporting the 3D model as an STL or OBJ file, which is a universal format for 3D printing. Lastly, slicing software such as Cura or 3D is used to convert the 3D model into a set of instructions, or G-code, that the printer can understand. To achieve this, the software divides the model into thin, horizontal layers and determines the optimal path for the printer to follow. 2. Printer setup. Printer setup involves several steps. First, select a 3D printer that meets the needs and is compatible with the material that is going to be used. Examples include fused deposition modeling, stereolithography, and selective laser sintering printers. Next, clean the build platform and apply an adhesive or surface treatment, if necessary, to improve adhesion and prevent warping. Finally, load the chosen material, such as filament for FDM printers or resin for SLA printers, into the 3D printer. Make sure it is properly fed into the machine. 3. Print process. The print process is the heart of the matter. Here are the steps to follow. Firstly, the G-code file should be uploaded to the printer by connecting it directly to a computer, using a USB drive or via Wi-Fi. Once the file is uploaded, the print can be started, and the first few layers should be monitored to ensure proper adhesion and correct printing. Next, the 3D printer will follow the G-code instructions, depositing material layer by layer. For FDM printers, the material is heated and extruded through a nozzle. For SLA printers, a light source cures the liquid resin, and for SLS printers, a laser sinters powder material. During the printing process, it is important to regularly check the print for any issues, such as layer separation or nozzle clogging. If any problems are identified, they should be resolved immediately to avoid print failure. By carefully monitoring the print process, the best possible results can be achieved. 4. Post-processing. After a 3D print job is finished and the object has cooled or cured, there are several post-processing steps that should be taken to ensure the object is ready for use. Firstly, the print must be carefully removed from the build platform using an appropriate tool, such as a spatula. If the model required supports, these must be removed using pliers, a hobby knife, or other suitable tools. It is important to be cautious not to damage the object during these steps. Next, for SLA prints, the object should be cleaned using isopropyl alcohol to remove any uncured resin. SLS prints require the removal of excess powder. After cleaning, the surface of the object should be post-processed by sanding, filing, or polishing it to achieve the desired surface finish. Paint or other treatments may also be applied for aesthetic or functional purposes. Finally, if the object consists of multiple parts, they must be assembled according to the design. By following these post-processing steps, the printed object will be ready for use. 5. Quality control and testing. Once the post-processing steps have been completed, it is important to perform quality control and testing to ensure that the printed object is of the desired quality and meets the intended requirements. The first step in this process is to inspect the print for any defects, such as layer separation, warping, or inaccuracies. If any defects are found, appropriate measures should be taken to rectify them. If the printed object serves a functional purpose, it is important to test its performance to ensure that it meets the intended requirements. This may involve load testing, stress testing, or fitting with other components. By testing the functionality of the printed object, Any issues can be identified and addressed before it is put to use.